Introduction. Microplastic contamination poses environmental and health risks as fragmented plastics become widespread in marine ecosystems. Chitosan, a biopolymer from chitin, has shown high efficiency in filtering microplastics, though previous studies lacked scalability testing and integration with automated technologies like Arduino. This study aims to create a microplastic filter. The product detects and extracts microplastics with specific functionalities designed for this purpose. Additionally, the microplastic filter is programmed using the Arduino interface. Future researchers can utilize the findings of this study to validate the accuracy of other research, aiding in resolving issues in their investigation. Variables. This study utilized chitosan derived from crab and shrimp shells for wastewater treatment. It also incorporated the Arduino interface, a programmable electronics platform, to automate processes. The combination of Chitosan and Arduino enhances microplastic filtration and improves public health safety. Number 1. What is the accuracy of the microplastic in detecting microplastics in various concentrations? Number 2. What is the effectiveness of the microplastic filter in extracting microplastics from water? Number 3. What is the average time for the microplastics to be filtered using the microplastic filter? And number 4. What is the effectiveness of the microplastic filter in removing microplastics of different sizes?
Research procedure. The procedure shows the step-by-step process of how to make a Chitosan-based Arduino enhanced filter for microplastic extraction and detection. First, ensure protection and maintaining safety. Second, extracting Chitosan. Third, creating the Chitosan filter. Fourth, making the microplastic detector case. Fifth, creating the microplastic detector and extractor. And lastly, programming and uploading the commands. Here's the schematic diagram of the research device. On the left, the wirings and the Arduino Uno microcontroller are seen inside the box. Then the turbidity sensor is enclosed by a small plastic box. Next, you have a tube connected by a valve in the middle and is connected to the aquarium filter where the water will flow and is filtered with the Chitosan-based filter. On the right side, we can see the circuit diagram of the device, where the turbidity sensor, servo, and power supply are all connected to the Arduino Uno microcontroller.
Results. Number 1. Accuracy of the microplastic filter in detecting microplastics in various concentrations. The microplastic filter exhibited 100% detection accuracy at all tested concentrations, 6 grams, 10 grams, and 20 grams per liter. Each concentration level was subjected to 3 trials, and all trials resulted in detected outcomes. Number 2. Effectiveness of the microplastic in extracting microplastics from water. The filter extracted an average of 8.33 grams of microplastic per liter from an initial concentration of 10 grams per liter, showcasing its high effectivity. The 3 trials resulted in 7 grams, 10 grams, and 8 grams of extracted microplastics, demonstrating consistency in removal performance. The weight of microplastics extracted was calculated by subtracting the initial Chitosan filter weight, 3 grams, from the final recorded weight after filtration. Number 3. The average time for the microplastics to be filtered using the microplastic filter. The microplastic filter took an average of 44.33 seconds to filter water samples with a concentration of 10 grams per liter of microplastics. The specific trial times were 44 seconds, 42 seconds, and 47 seconds, respectively, with a low variation. Number 4. Lastly, effectiveness of the microplastic filter in removing microplastic of different sizes. For medium-sized microplastics, 1 to 2 millimeters, the filter achieved an average removal of 8 grams per liter, with trial results of 7 grams, 9 grams, and 8 grams. For large-sized microplastics, 2 to 5 millimeters, the filter achieved an average removal of 9.33 grams per liter, with results of 10 grams, 8 grams, and 10 grams. Overall, the filter exhibited an 80 to 93% removal effectivity for both sizes, indicating its high filtration effectivity across varying microplastic sizes.
The microplastic filter demonstrated consistent and high effectiveness in removing microplastics from water. Using a Chitosan-based filtration medium proved effective in separating microplastics. These findings aligned with previous research highlighting Chitosan's potential as a sustainable and biodegradable absorbent for water treatment applications by Chen et al. 2022. The filter's performance across size categories 1 to 2 millimeters and 2 to 5 millimeters demonstrated its adaptability, achieving average removal rates of 80 to 93%. Conclusion. The filter consistently demonstrated reliable performance across varying microplastic sizes and concentrations, achieving high detection rates and significant removal effectiveness. By accurately quantifying the extracted microplastics, this study validates the filter's potential for application in sustainable water treatment systems. Further research is recommended to refine the filter design and enhance its small capacity to target smaller microplastic particles and dissolve contaminants.